Hello everyone. Today we'll be converting between rectangular and polar coordinates. Okay, so we've started looking at polar coordinates last section, and today we're going to go back and forth between polar coordinates and rectangular coordinates because one can be more convenient in some cases, while the other can be more convenient in other cases. So it's important that we can convert them back and forth between polar and rectangular. So let's imagine that we have a point xy here. So this is in rectangular form. And let's say we want to convert this to polar form. Then what you would do is you form, remember this would be this distance right here would be the rho in polar form, right? That's the radius. And this right here would be the angle we're looking for in the polar coordinates. So if we have rectangular form x and y, then to get that, remember that distance right there, this, I'll need to start writing on this. This right here is the y. This right here is the x, right? That's the distance we've gone in the x direction, and that's the distance we've gone in the y direction. So to get rho, we just need to use the Pythagorean theorem. So that squared is going to equal x squared plus y squared. And to get rho, you'll need to just take the square root of that, x squared plus y squared. And for the theta, you'll realize that this is the opposite side and this is the adjacent side of that theta. So if you take tangent of that theta, you're going to get y over x. So to get theta, you just need to take the arctan. Okay, so these are the conversions you can use to go from rectangular to polar. Okay, now how about if you want to go from polar to rectangular? So let's say we know that we know the radius and we know the theta. Then how can you get x and y from that? Well, think of the unit circle. And on the unit circle, we have the x's and y's. The x on the unit circle is cosine of theta, and the y is sine of theta, right? And that tells you that by taking those trigonometric functions, you're going to end up with the x component and the y component. And in fact, cos of theta is going to give you, to be more specific, it's the adjacent over the hypotenuse, right? So that's going to be x over rho. Sine is going to be the opposite over the hypotenuse, y over rho. And the reason it was just cos theta and sine theta, or the reason that cos theta equaled x over rho and sine theta equaled y over rho on the unit circle is because the rho equals 1, right? The radius equals 1. But the radius might not necessarily equal 1, so we can't just ignore the rho here. So to switch this into just x, we'll have to multiply by rho. If you multiply by rho, then we'll just end up with x, right? So to go from here to x, we'll have to multiply that by rho, right? Because cos theta is the same thing as x over rho. So let me write this out more neatly down here. So cos theta equals x over rho. According to the Pythagorean property, it's the adjacent over the hypotenuse. Adjacent over hypotenuse. Therefore, rho times cos theta will just equal x, right? And similarly, sine theta equals y over rho. So rho sine theta is going to equal y. So this is the conversion you can use to go from polar to rectangular. So you know rho and theta if you're in polar coordinates. So that's going to give you the x, and that's going to give you the y. Okay, so these are the conversions you can use to go back and forth between polar coordinates and rectangular coordinates. This is going from rectangular to polar, and this is going from polar to rectangular.